So I have an expression here, and I'd like to go through this completing the square process with it. And what makes this one a little interesting, a little different from the previous ones we've looked at, is that 2 that's out in front of the x squared. The method that we've used previously, and that we're ultimately going to use here, doesn't work if there's a number out there in front of the x squared term. So we're going to do almost the same thing. There's just going to be an extra step to kind of resolve that issue. So first, just to be clear, our goal here is to rewrite this polynomial so that it looks like this. Some number times a linear factor squared plus another number. All right, so I'm going to take this and I'm going to set it off to the side here because I don't want to lose track of that. It's always a good idea to keep your final goal in mind. And I'm going to start off with the original polynomial. That's just the one from the question. So the first thing I'm going to have to do is I'm going to have to handle that 2. Right? And that's actually not hard to do. All I'm going to do is factor it out. Right? But I'm going to be a little careful about this. I'm only going to factor it out of the first 2 terms. Because it's those first 2 terms that kind of play a role in the completing the square process. The 2 at the end is just sort of along for the ride. Okay, now I'm going to do the exact same process we've done before, just on the x squared plus 3x part that's inside the parentheses. So again, like before, I'm going to focus on that 3. I'm going to divide it by 2 and square it. That's going to give me the number that I have to add to that x squared bit to turn it into a perfect square. Now watch again how I do this, right? I'm going to slip it inside the parentheses. It needs to go right in there with the polynomial part. Now, again, just like before, I can't do that. We can't just go randomly adding numbers to our expression here. So I'm going to have to subtract it back out to balance things. But here's another little subtle part. I didn't actually add 9/4. What I added was 2 times 9/4 because of that 2 outside. So what I'm going to do to balance that is I'm going to subtract 2 times 9/4, which is 18/4. And now everything is still in balance. This is still equivalent to the original expression. So now I'm going to factor the parentheses. And just like before, if it isn't clear to you how to factor something when it's got a fraction in it, because it's not something we normally do, look to that 3/2 squared part. Right? The number that we squared over there, the 3/2, that's going to be the number that appears inside the factorization. So when I do that, this is going to become 2 times x plus 3/2, quantity squared, plus 2 minus 9/2. I reduced the fraction because now I got to combine the 9/2 and the 2. That means a common denominator, and that's just marginally easier if the numbers are smaller. So 2 is 4/2. 4/2 minus 9/2 is negative 5/2, and there's my final result. Right now, I'm gonna take from that upper right hand corner. I'm gonna take that expression. I'm gonna bring it back down here, so we can compare it. And you see, yeah, we did do exactly what I said we needed to do. A is gonna be 2, B is gonna be 3/2, C is gonna be negative 5/2. And so that's the procedure for completing the square when I'm going to be a little technical here, when the coefficient of the x squared term is something other than just positive 1. Okay, so if you found this example helpful, please don't forget to click on the like button down below. And there's some links here to some additional videos, including one where I derive where that 3/2 comes from. Right? Where does the formula come from that we use to get that special number that we add in here?